The morning of June 6, 1944, arrived with devastating darkness. At 1400 hours, 13,100 American paratroopers launched themselves into the French night, each man strapped with 88 pounds of gear. Parachutes snapped open above the drop zone as anti-aircraft fire ripped through the C-47 transport planes. Men fell scattered across the Norman landscape, some landing kilometers away from where they were supposed to be, separated from their units and disoriented in the chaos. The first priority was finding weapons. Army protocol said everything should work smoothly. Open the Griswold bag, remove the 3 pieces of disassembled M1 rifle. Thread the barrel into the receiver, lock it down, insert the clip. 40 seconds total, that was the plan. Doctrine assumed paratroopers would have 40 seconds to accomplish this task. But German soldiers moving through those darkened hedgerows knew something different. They only needed 10 seconds. In the scattered darkness, with the enemy already firing, American paratroopers learned what the technical manuals had never revealed. The gap between a weapon that looked perfect on engineering drawings and one that actually functioned when your hands trembled and bullets were flying past your head. The United States Army had roughly 12 months to solve a crisis that was costing soldiers their lives faster than combat itself. The answer would come from an unexpected direction entirely. Fort Benning, Georgia, March of 1942. The Army was churning out paratroopers faster than it could figure out how to properly equip them. On the training drop zones, instructors watched the same frustration repeat itself day after day. A problem with no clear solution. Every paratrooper carried nearly 40 kilos hanging from his harness when he jumped. Rations, spare clothing, shovels, hand grenades, Hawkins mines, gammon bombs, reserve parachute, main parachute, ammunition, medical kits. Somewhere in all that equipment, somehow attached to an already overloaded harness, each soldier also carried his rifle. The M1 rifle represented the pinnacle of American firearm engineering, 9.5 pounds of American-made steel, 43 6/10 inches long, chambered in 30-06 Springfield, firing a 150-grain bullet at 2,800 feet per second with the stopping power to drop a target at 500 yards. It stood as the finest general-purpose infantry rifle anywhere in the world. But it was absolutely unsuitable for paratroopers. The solution the Army had created was the Griswold bag, a thick canvas container meant to shield the rifle during descent. The theory promised flawless execution. Secure the bag to your harness before boarding the aircraft. Jump from the plane at 120 miles per hour. Withstand the shock as the parachute deploys. Land safely. Open the bag. Take out 3 rifle pieces. Connect the barrel to the receiver. Lock the mechanism. Load an 8-round clip. Chamber a round. Engage the enemy. The engineering drawings stated this could happen in 40 seconds by a trained soldier under ideal circumstances. But actual reality painted a different picture. During training exercises at Fort Benning, soldiers encountered challenges the engineers had simply not foreseen. Rifles snagged on undergrowth as they moved. The rifle's 43-inch length struck helmet backs, slipped off shoulders, made standard field packs impossible to wear properly. Men who jumped with rifles attached to their harnesses hit the ground hard and scrambled for defensive positions while wrestling with canvas straps and loose metal pieces. Meanwhile, on the other side of the Atlantic, Germany was demonstrating what airborne forces could actually accomplish. Glider-borne soldiers and paratroopers executing lightning strikes through Belgium and Holland. Taking Fort Eben-Emael. Invading Crete. Every German success demonstrated that speed and surprise could defeat larger forces, provided the attacking troops possessed superior equipment. The United States Army Ordnance Department sent out an urgent call. Design a compact, lightweight weapon for defensive use, something with greater range, accuracy, and hitting power than a standard handgun. It had to weigh half what the Thompson submachine gun or M1 rifle weighed. It had to be something paratroopers could actually carry into battle without destroying their bodies or losing their ability to move freely. The answer emerged in 1941. The M1 Carbine. Weighing 5.2 pounds and measuring 35.6 inches long, it was roughly half the weight and half the length of the rifle. Chambered in .30 carbine ammunition Measuring 7.62 by 33 millimeters, it fired a 110-grain bullet at 1990 feet per second, producing 967 foot-pounds of energy at impact. This delivered roughly twice the power of the Thompson's 45 ACP round, with considerably superior range and accuracy. The effective firing distance reached 300 yards, which was appropriate for the close-quarters fighting paratroopers anticipated behind enemy lines. For airborne troops, it appeared ideal, light enough to jump with, tough enough to fight with. The 15-round detachable magazine meant sustained firepower far exceeding the rifle's 8-round clip. Manufacturing started immediately. Eventually, more than 6 million M1 carbines rolled off production lines, more than any other American military small arm throughout the entire Second World War. Yet a significant problem persisted. Even at 35.6 inches, the M1 carbine remained too long for safe parachute operations. Paratroopers needed something that could be strapped securely to their bodies during the violent moment of exiting a C-47, withstand the opening shock of the parachute, and critically be ready for immediate combat action. Not after 40 seconds, not even after 20 seconds. Instantly. Early in 1942, Army Ordnance released another request. This time, they wanted a carbine with a stock that either folded or collapsed. The importance could not be overstated. America was creating airborne divisions at extraordinary speed. The 82nd and 101st Airborne Divisions were already conducting intensive training for combat missions everyone understood were approaching. Europe burned. The Pacific erupted in chaos. Each week without a solution represented another week that paratroopers would deploy into battle, carrying improvised, inadequate weapons. Every training jump at Fort Benning served as a painful reminder that the present system simply did not work. 3 manufacturers submitted proposals. 2 were deemed unacceptable. The Army offered no explanation for the rejections. There was no time for explanations. The third proposal came from an unlikely source. Inland Manufacturing Division of General Motors, based in Dayton, Ohio. The company began in 1922 producing steering wheels wrapped in wood for automobiles, working from a former Dayton Wright Airplane Company building. 2 decades later, they had become a major M1 carbine manufacturer. Before the war ended, Inland would produce 2.6 million carbines, representing 43% of all M1 carbines made during the entire conflict. These were automotive engineers, not traditional gunsmiths. They approached problems through mass production principles, practical field reliability, and ruggedness under harsh treatment. They designed for the 10,000th unit made under the worst conceivable conditions, not the first prototype in a controlled laboratory. Inland submitted initial drawings in March 1942. The Army reviewed them and requested modifications. Time was disappearing. The 82nd Airborne was set for deployment. Intelligence suggested significant airborne operations were being prepared for North Africa. Sicily, perhaps. Possibly France itself. The weapon had to be ready. On April 29, 1942, Inland's revised drawings received recommendation for standardization as the model M1A1. On May 12, 1942, official approval came through. They possessed 6 months to demonstrate it would function in actual combat before paratroopers carried wrong weapons into history's most decisive battles. Inland's engineers grasped something fundamental that separated them from traditional weaponsmiths. The solution did not need to be revolutionary, it simply needed to work. Every single time, under the absolute worst possible circumstances. The Inland design was elegantly straightforward, a side-folding stock that could fit any carbine action, replacing the standard full-length wooden stock found on the regular M1 carbine. A wooden pistol grip served as the handle. A spring-loaded wire stock folded flat against the left side. Folded, the overall measurement was 25 inches. Extended 35.6 inches, exactly matching the standard M1 carbine. The weight stayed at 5.2 pounds. The real innovation was what was deliberately omitted. There was no locking mechanism. The stock neither locked in the open nor closed position. A spring-loaded cam held it in place instead. Some Army Ordnance engineers considered this a potential flaw. Inland knew better. It was actually a strength. A lock mechanism meant additional moving parts, potential failure points, precious seconds wasted struggling with latches or releases during combat. The spring-loaded cam was immediate, intuitive, absolutely reliable. A soldier could snap the stock open using just one hand in complete darkness without conscious thought. No buttons, no levers, no thinking required. Simply push the stock until the cam engaged. The design assumed soldiers would be exhausted, scattered, possibly wounded, certainly terrified, and it functioned flawlessly anyway. This represented automotive engineering applied to weapons manufacturing. Inland's designers had invested 20 years perfecting car door hinges, hood latches, steering column mechanisms. They understood that devices needed to perform for ordinary operators under pressure, not merely for specialized technicians in perfect conditions. They designed for the 10,000th paratrooper on the 10,000th jump, not the first test rifle in a factory workshop. Inland distributed specialized tasks among partners. S.C. Overton Company of South Haven, Michigan, manufactured the wooden parts. Pistol grips were machined using furniture production methods adapted for wartime output. Royal Typewriters Incorporated of Hartford, Connecticut, fabricated the wire stock and initially managed final assembly. This was not precision gunsmithing. It was automotive-scale manufacturing translated into weapons production. The rivets securing the stock together were automotive brake shoe rivets, proven components with established failure rates and known stress limits. The leather cheek support on the wire stock employed methods directly inherited from automobile upholstery. Techniques for cutting, stitching, and attachment had been perfected through decades of car manufacturing. Each component was chosen specifically because it could be mass-produced, field-repaired if necessary, and subjected to rough handling without complete failure. Royal Typewriters struggled initially with assembly procedures. The records were kept close, but somewhere around the middle of 1942, things began to slip behind schedule. The entire program faced the real possibility of falling apart. Then S.C. Overton stepped up and took the whole assembly operation onto its shoulders, shipping completed folding stocks straight over to Inland's facility in Dayton. This wasn't about one contractor trying to outdo another or prove something. It was pure practicality in service of a larger goal. When Royal Manufacturing couldn't keep pace, Overton filled the gap without waiting for paperwork to shuffle through channels. Once the weapons reached Dayton, the assembly work followed a straightforward method. Complete M1 carbine actions arrived ready to go. Receiver, barrel, bolt, trigger mechanism, every working part that made the gun fire. These came off the main production line and went directly into M1A1 folding stocks instead of the standard wooden ones. The internal action stayed exactly the same. The firing mechanism worked identically. What changed was nothing more than what the soldier held onto. Serial numbers came from whatever sequence Inland had reached when the folding stock got attached. There was no separate numbering system for the M1A1. Nobody treated it as some brand new weapon that needed its own tracking system. It was simply the same reliable M1 carbine mechanism, just wrapped in a different package. A package built from the ground up for paratroopers who needed something they could operate from tight spaces without losing any stopping power. This design choice rippled through everything: how supply lines worked, what training soldiers needed, how repairs got done. Armorers who already knew the M1 carbine inside and out could fix the M1A1 without sitting through new classes. Parts swapped between them without any problems. The ammunition was the same. Only the folding stock itself required something special, and even that could be swapped for a regular stock if a paratrooper needed to improvise in the field. The first shipments reached the 82nd and 101st Airborne in October of 1942. That first batch came to roughly 71,000 M1A1 carbines, delivered month after month from October 1942 straight through to October 1943. Along with the rifles came gear designed specifically for men who jumped from planes. The jump scabbard was essentially a padded canvas sleeve that hooked onto a paratrooper's pistol belt up top. A strap ran down to theoretically secure around the ankle, meant to keep the folded weapon pressed tight against the leg during the jump. Picture 25 inches of firepower wrapped in canvas, ready to go the moment boots hit ground. Except theory ran into something harsher when men actually jumped. Field reports and early combat showed that ankle strap caused real damage when people landed. A paratrooper carried 88 pounds of gear plus body weight, falling at roughly 20 feet per second, and if a 5-pound carbine was strapped to the ankle, the physics became brutal. That concentrated force on impact could snap bones. Paratroopers stopped using it and invented their own solutions instead. Some tucked the folded carbine behind their reserve parachute, using the existing harness straps to hold it secure. Others rigged ways to carry it across the chest or slung it over the back, discarding the official scabbard entirely. The Army never formally approved these workarounds, but it didn't crack down on them either. Combat teaches fast lessons about what actually works and what gets people killed, and the weapon did work. The spring-loaded catch held through the violent opening shock of parachute deployment. The stock snapped open instantly when boots touched down. The same M1 carbine action that had earned its reputation for reliability in standard form kept that reliability in the airborne configuration. What soldiers experienced in training drops, however, wasn't quite the same as what came in actual battle. The real proving ground was still waiting. July 1943 brought the invasion of Sicily, and the M1A1 got its first taste of combat fire. American paratroopers dropping in darkness found themselves scattered across the Sicilian landscape in precisely the scenario that had sparked the original request for a folding carbine 15 months earlier. Men landed isolated, often surrounded by enemy forces, forced to engage immediately with whatever they had. The M1A1 delivered. No time wasted taking apart components, no reassembly process to fumble through in the dark. Paratroopers jumped, opened the stock, chambered a round, and started returning fire within seconds of hitting the ground. The spring-loaded catch held solid. The wire buttstock didn't collapse under recoil. The gun performed exactly as Inland's engineers had drawn it up on their blueprints, simple and dependable, every single time. Sicily proved the concept worked, but the real test still lay ahead. June 6, 1944, changed everything. Roughly 13,100 American paratroopers from the 82nd and 101st Airborne filled C-47 transport planes for what would become the biggest airborne operation ever attempted. The 101st alone put 6,128 men in the air. The 82nd's Boston mission carried 6,420 paratroopers spread across 369 aircraft. Loaded down with T-5 parachutes and nearly 40 kilos of equipment each, they lifted off just before midnight on June 5th. By 1:15 in the morning on June 6th, they were jumping into Normandy. Trouble started the second the doors opened. A thick cloud bank sat over the Cotentin Peninsula, forcing pilots to climb higher or drop lower to avoid smashing into each other. German anti-aircraft fire scattered the fleet even worse. The drops turned into complete chaos. Men who should have landed in tight units found themselves alone in Norman farmland, sometimes 50 or 60 kilometers from where they were supposed to be. Soldiers jumped carrying more than 60 pounds of equipment, held on with tie-downs that looked strong enough in training, but tore apart under real conditions. Griswold bags split open. Ammunition pouches disappeared into the darkness. Grenades and mines vanished. Paratroopers ran through fields deep behind enemy lines, searching for their gear and weapons on landing zones, while German patrols swept toward them through the gloom. But men who had an M1A1 tucked behind their reserve chute or secured to their harness had something the others didn't. Their weapons were ready to go. Not in 40 seconds after digging through bags. Right then and there, Lieutenant Richard Winters of Easy Company, 506th Parachute Infantry Regiment, led one of the battles that soldiers still talk about decades later. At a place called Brecourt Manor, his men attacked German artillery positions hammering away at Utah Beach. They used M1A1 carbines to pick off German gun crews from hedgerow positions, holding them pinned while flanking elements worked into closer range. The lighter carbine let men move faster through the thick bocage terrain. The 15-round magazine meant sustained fire without stopping to reload. Photographs from that day show M1A1 carbines weren't confined to drop zones where paratroopers landed. They showed up on the beaches themselves. A picture from Omaha Beach caught a soldier from the 16th Infantry Regiment pressed against the base of chalk cliffs, brushing sand off an M1A1. The weapon had somehow made it through all the confusion from an airborne unit to a regular infantryman who recognized quality when he saw it. Guns drifted to wherever they were needed most, regardless of what the paperwork said about allocation. The cost in lives told the real story. Across the entire operation, 2,499 American paratroopers became casualties. In the 82nd Airborne alone, 15 of the 16 battalion commanders fell dead or wounded. The casualties stung. The scattering turned out worse than anyone had prepared for, and German resistance proved sharper than intelligence officers had promised. But losses would have been truly catastrophic without the M1A1. Every paratrooper who landed with a loaded gun ready to fire instead of rifle parts stuffed in a bag had better odds in those first seconds after hitting ground. The edge between walking away and not coming home often depended on who could shoot back first. Work through the math. Paratroopers landed 50 kilometers from objectives, isolated behind enemy lines, facing German defenders with stronger positions and heavier firepower in many cases. The M1 Carbine reached out to 300 yards effectively, which handled the close-quarters fighting that ruled the Norman hedgerows just fine. The landscape itself, endless small fields chopped up by ancient earthen walls crowned with thick hedges, demanded weapons that worked at distance. Perfect ambush country, perfect close-range killing ground. Hedgerows made everything a short-range engagement. In those conditions, the second or two saved by carrying a weapon already loaded and ready cost lives when men had to scramble for cover. German soldiers who ran into scattered American paratroopers in the hours after the drop reported shock at how quickly the Americans organized defensive lines and opened fire. Germans had expected chaos and panic from isolated soldiers wandering behind enemy lines. What they found instead was organized resistance from men equipped with working weapons in their hands. The M1A1 showed up in every American airborne operation that followed. September 1944 brought Operation Market Garden, the massive push to seize bridges spanning the Rhine through Holland. March 1945 brought Operation Varsity, the jump across the Rhine into Germany itself. Whenever American paratroopers went into combat during the rest of the war, many of them gripped M1A1 carbines, and each time the simple folding stock design worked exactly as the engineers at Inland had intended from the start. The weapon had proven itself in the worst situations imaginable: scattered drops in darkness, flooded fields, dense hedgerow country, urban combat, every environment that tested a gun's ability to keep functioning. Mud, water, sand, the shock of landing with equipment strapped on. The M1A1 encountered every challenge and kept working. The spring-loaded catch never gave way. The wire stock never collapsed. The simplicity that had made some engineers skeptical turned into the design's greatest asset. No complicated mechanisms to jam, no delicate parts to snap, nothing that could fail between the jump and the first shot. Production ramped up again in April 1944, pushing out roughly 69,000 more M1A1 carbines from then through the end of that December. Combat from Sicily and Normandy had validated every choice the Inland designers had made. Nobody asked for modifications. No improvements seemed necessary. The gun worked, so production kept rolling. By the time manufacturing stopped, 140,591 M1A1 carbines had been built. Every single one rolled off assembly lines at Inland Division of General Motors. That single-source production made the M1A1 unusual in the World War II weapons world. Most successful rifles got made by multiple manufacturers. Springfield Armory built the M1 Garand alongside Winchester, Harrington and Richardson, and International Harvester. The standard M1 carbine came from 10 different contractors: Inland, Winchester, Saginaw, Rockola, Quality Hardware, National Postal Meter, Standard Products, Underwood Typewriter, IBM, and Commercial Controls Corporation. But the M1A1 stayed exclusively an Inland product. Part of that came down to logistics. The folding stock needed specialized subcontractors already woven into Inland's supply network. Part came down to timing. Approval came in May 1942, with deliveries starting in October. That 6-month window didn't leave room to build new production lines elsewhere. By the moment other manufacturers could have ramped up M1A1 production, Inland was already shipping working weapons to combat units. The single manufacturer approach created quality control advantages that became obvious fast. The M1A1 stocks got made in far smaller numbers, with far fewer variations, over a much shorter span of time compared to standard M1 Carbine stocks. Inland held consistent measurements across all 140,000 units. When an armorer picked up an M1A1 in the field, they knew exactly what they had in their hands. No differences between manufacturers. No compatibility headaches from parts made in different places. One company, one design, one standard. That clarity showed itself when comparing the M1A1 to the M1 Garand. The Garand weighed 9.5 pounds, nearly double the M1A1's 5.2 pounds. The Garand measured 43.6 inches long, almost 19 inches longer than the folded M1A1. The Garand fired .30-06 cartridge with power that worked out to 500 yards. The M1A1 fired .30 carbine, effective to 300 yards. Two completely different weapons serving completely different needs. On paper, the M1 Garand was clearly the superior weapon. More firepower, greater range, exceptional stopping power. General Patton himself had declared it the greatest battle implement ever created, and for conventional infantry combat, he wasn't wrong. But when paratroopers descended at 120 miles per hour while carrying 88 pounds of gear, those advantages transformed into serious drawbacks. Extra power meant extra weight. Extended range meant extended length. The very strengths that made the Garand formidable became liabilities for men falling from the sky. The Garand's capabilities simply didn't align with what airborne soldiers actually needed. The M1 Carbine wasn't attempting to replicate the Garand's performance. It was tackling an entirely different challenge. For troops who had to manage a weapon during a violent parachute descent, survive the brutal impact of landing, and engage enemy forces within seconds, the M1 Carbine delivered precisely what the mission demanded. It offered adequate firepower in a package roughly half the weight of its larger cousin, and when the stock folded, it shortened by 41%. This fundamental understanding had been the driving force behind Inland's automotive engineers from day one. The superior weapon for any particular mission wasn't necessarily the most powerful, most accurate, or longest-ranged option available. It was the one that actually functioned under the specific conditions where it would be deployed. Paratroopers didn't need to hit targets at 500 yards. What they needed was to survive the opening minute after landing. The M1 Carbine was engineered for exactly that, and nothing else mattered. Though limited quantities reached the United States Marine Corps Airborne Regiment, Marine paratroopers never saw actual combat drops. The Marines disbanded their airborne units eventually, reassigning personnel to standard infantry roles, but the weapons stayed in service. Following the war, M1 carbines were distributed to American allies through military assistance initiatives. French paratroopers carried them through Indochina during the first conflict there, notably during the defense of Dien Bien Phu in 1954. Additional combat service came later during Vietnam, where both American Special Forces and South Vietnamese troops valued the compact design for jungle operations. The folding stock concept proved so effective that Inland's engineers created several variants. During May 1944, they produced the T4 conversion kit, adding selective fire capability to the M1 carbine platform. This development led to the M2 carbine, which could fire both semi-automatically and fully automatically. Most M2 versions used standard wooden stocks, but the M2A1 featured the folding design, merging the compact airborne package with sustained automatic capability, creating something resembling a modern submachine gun in both performance and handling. By late 1944, the M1 carbine had become the standard weapon across American airborne formations. It had proven itself repeatedly in Sicily, Normandy, southern France, and countless smaller engagements. Manufacturing efficiency had reached optimal levels. Quality remained consistent across every unit produced. The entire supply chain flowed smoothly from the inland assembly facility to airborne units scattered across Europe and the Pacific. The system operated precisely as Army Ordnance had envisioned when requesting a folding carbine back in early 1942. What began as an urgent requirement had transformed into a battle-tested system within less than 3 years. From Inland's initial patent filing on August 5, 1942, through Sicily, D-Day, Market Garden, and Operation Varsity, The M1 Carbine demonstrated that flawless simplicity surpasses complexity that might fail. 140,591 weapons, each manufactured to identical standards, each featuring the same spring-loaded cam mechanism that required no locks, no intricate systems, nothing that could malfunction when a paratrooper's life depended on it. The story was already being etched into the Norman fields and Belgian forests. The M1 Carbine hadn't displaced the Garand, it never intended to. It simply addressed the specific problem it was built to solve, equipping paratroopers with reliable weapons the instant their feet touched ground. September 1944 brought Operation Market Garden, the largest airborne operation the world had yet witnessed. American, British, and Polish airborne forces descended into the Netherlands attempting something bold, seizing Rhine crossings to finish the war before Christmas arrived. American paratroopers jumped carrying the same M1 carbines that had proven themselves 3 months earlier in Normandy. Strategically, the operation collapsed. Allied intelligence had somehow overlooked 2 SS Panzer divisions preparing in the Arnhem area. The memorable phrase, "a bridge too far," encapsulated the overambition. The strategy relied on speed and surprise, overwhelming German defenses. It counted on capturing bridges before German reinforcements could arrive. It miscalculated. Yet at the tactical level, where individual soldiers fought and fell, the M1 Carbine performed flawlessly. Paratroopers landed with functional weapons in their hands. They established positions for defense immediately. Facing German armor with overwhelming firepower, they were still never disarmed. They weren't struggling with rifle parts while tanks rolled closer. The weapon wasn't the problem. The strategy was. One genuine constraint did surface during prolonged combat, though designers had acknowledged it beforehand. The folding metal stock wasn't optimal for firing rifle grenades. The Garand's rigid wooden stock could withstand the powerful recoil of grenade discharge without damage. The M1 Carbine's wire stock, designed for minimal weight and maximum compactness, could bend or fracture under identical stress. Official Army directives addressed this reality. The M1 Carbine wasn't intended for grenade launching except during emergencies. Even then, procedure called for folding the stock and pressing the pistol grip firmly against the ground, using earth itself to absorb recoil rather than straining the folding mechanism. This wasn't a design flaw. It represented an intentional choice. Inland's engineers had confronted a difficult trade-off. Building a folding stock capable of withstanding grenade launches would require heavier wire gauge, extra bracing, and more sophisticated construction, all increasing weight, compromising reliability, and prolonging production schedules. Alternatively, they could focus on the primary mission, providing paratroopers a lightweight, compact weapon, deploying instantly with consistent accuracy. They selected the second path. Given the actual circumstances paratroopers encountered, this decision proved correct. Most engagements happened within 200 yards, across terrain where rifle grenades offered minimal benefit compared to thrown grenades or standard fire. Paratroopers required weapons functioning the moment they landed. Grenade capability was convenient but not critical. Weight reduction and instant deployment were essential. The proof came written through survival statistics. Paratroopers equipped with M1 carbines experienced substantially better outcomes during those vital first moments after landing compared to earlier operations where soldiers carried disassembled rifles. Exact casualty reductions were impossible to calculate precisely. Too many factors influenced combat survival, yet experienced paratroopers and commanders consistently noted that the M1 carbine gave them a real fighting chance when scattered drops left them isolated and vastly outnumbered. The weapon's reputation wasn't built on dramatic technological breakthroughs, but through dependable, unglamorous reliability. 140,591 M1 carbines emerged from factories. Each incorporated the identical spring-loaded cam. Each utilized automotive brake shoe rivets. Each was constructed by workers trained making automobile components rather than firearms, and every single one functioned. This illustrated a broader principle guiding World War II weapons development. The most effective weapons rarely represented the most advanced technology. The M1 carbine succeeded because it delivered exactly what conditions demanded when they demanded it, consistently. Nothing superfluous, nothing insufficient. Inland's engineers resisted adding capabilities, surpassing mission performance specifications, or displaying engineering brilliance. They manufactured a practical tool, not an exhibition piece. Production figures spoke volumes. Inland's manufacturing division produced 2,600,000 M1 carbines, overall during wartime, accounting for 43% of all M1 carbines made. The M1A1 represented just 5% of Inland's carbine output, but that 5%, 140,591 units, equipped every American paratrooper through war's conclusion. The production timeline told its own story. Design approval came May 12, 1942. Initial deliveries arrived October 1942. Combat introduction happened Sicily, July 1943. Normandy came June 1944. Market Garden, September 1944. Operation Varsity followed March 1945. 12 months separated concept from combat deployment. 20 months passed between first deliveries and battlefield validation on D-Day. This wasn't peacetime weapons development, where programs stretched across generations. This represented wartime necessity transformed into working hardware. Inland filed a patent application for the M1A1 folding stock on August 5, 1942. Patent number 1445158 received approval August 13, 1946, nearly 12 months after fighting ended. By then, patents held no significance. The design had already validated itself in the only lab that counted: real combat. The M1 carbine preserved lives not through raw destructive capability. American industry could produce far more powerful weapons. It saved lives not through cutting-edge innovation or revolutionary concepts. It saved lives because it addressed the right challenge in the most straightforward manner possible. Paratroopers needed weapons that functioned the instant they hit ground. Inland's automotive engineers, specialists who had spent 2 decades fabricating steering mechanisms before transitioning into weaponry, grasped something conventional manufacturers overlooked. During wartime, complexity becomes dangerous. Complexity generates additional parts susceptible to failure. More procedures demanding accuracy amid stress. More valuable seconds disappearing while adversaries advance. Simplicity endures. Simplicity substitutes a spring-loaded cam for elaborate locking systems. Simplicity replaces custom fasteners with automotive rivets. Simplicity delivers 140,591 identical weapons. Every single one manufactured identically, every single one functioning identically. Superior designs accomplish exactly what's required. Superior designs don't attempt everything possible. Superior designs accomplish precisely what becomes necessary. When necessity calls, they respond perfectly. Every occasion, without exception. The M1 carbine embodied this fundamental concept. Thousands of American paratroopers returned home because Inland's engineers understood this simple reality more profoundly than anyone else did.